Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today's discussion will be about the isometric projections of the combination solids, and in the three cases that we are going to discuss today, we'll see that hexagonal prism happens to be the common element amongst these three cases, right? So in the first case, we are going to pick up the construction of isometric projections of a cone which is resting centrally on top of a hexagonal prism. Whereas in the second case, the isometric projections of a sphere resting on top of a hexagonal prism will be discussed. And in the case 3, we are going to take up the isometric projections of a cylinder which is resting in the upright position with its axis perpendicular to the horizontal plane, and this cylinder will be resting centrally once again on the top of the hexagonal prism. So let us start with case number 1, that is the isometric projections of a cone which is resting centrally on top of a hexagonal prism. So here we have a hexagonal prism, and the edge of the base of this hexagonal prism is given to us as 20 millimeter, right? So this is one of the views which we have obtained. This is the side view, and if we look at the front view, you can check. This is the front view of this particular hexagonal prism, and it is resting onto the ground on one of its rectangular faces. So in the front view, we can find out that this hexagonal prism is resting on the horizontal plane on one of its rectangular faces, and its axis will be parallel to the horizontal plane. So first of all, we'll be starting with the construction of the hexagonal prism onto the ground, resting on one of its rectangular faces. Now in order to draw the hexagonal prism, what we need to do, step number 1, we have to draw the geometric construction of the hexagon in its true shape, and this is the hexagon that we are going to obtain, right? So once we obtain this hexagonal figure, now we are going to mark the points 1, 2, 3, 4, 5, 6. The edge of the hexagon we have taken to be equal to 20 millimeter as it was available to us from the side view. So in the side view, we could observe that the hexagon size is equal to H20. Now another thing we can see over here from this side view, that this cone diameter, it is matching with the edge view of this particular hexagonal prism. And in the front also, we have been told that the cone diameter is equal to 20 millimeter, and the height of the cone is given to us as 30 millimeter, right? So height of the cone is equal to 30 millimeter. So this 20 millimeter diameter is visible to us from the front view, and even from the side view, it is matching with the edge of this particular hexagonal prism. Now once we have drawn this hexagon, so we have marked all these 6 edges of the hexagon, and after drawing this hexagon, we know that the angles, they will not be preserved in the isometric projections, and the shape of this hexagon will also not be preserved in the isometric projection. So we have got a hexagon figure in which the edges 2, 3, 3, 4, 5, 6 and 6, 1, they are the non-isometric lines. So whereas in this hexagon there are only 2 edges, 1, 2 and 4, 5, which will be lying along the isometric line. So what we have to do, we have to inscribe this hexagon that we have drawn as a geometric figure into a rectangular figure over there. So please check, we have inscribed this hexagon into a rectangle, and the name of the rectangle we have labeled as A, B, C and D. And into this rectangle we have observed that there is a longer edge AB which we have marked as distance X, and there is a shorter edge of this rectangle which is having this side BC, and this will be represented by distance y over there. Now since this rectangular face, it is resting on the surface, on the rectangular face, so this shape of the hexagon, so this will be drawn along the x y axis over here. So this is our x axis, that is an isometric axis, so this has been drawn at an angle of 30 degree. Now this is our z axis, which has been drawn again at an angle of 30 degree. So the height of this particular hexagonal prism will be drawn along y direction over here. So this is the height, which is y, so it will be drawn along y direction, and this longer edge, this will be drawn along the x axis over there, so that this rectangular face, that is ABCD, so this will be drawn along x and y dimension. And whatever is, you can check the length of this particular prism, so the length of this prism will be represented along the z axis. Now in order to draw all these dimensions onto the isometric projection plane, now we have to first of all start with construction of the isometric scale. Now in the isometric scale, the true length scale will be drawn at an angle of 45 degree, and the isometric scale will be constructed at an angle of 30 degree. So all the distances from the true length scale, they will be transformed, they will be converted into the isometric lengths, and then whatever lengths they are given in the true shape into this figure, so all those lengths, they will be converted into isometric lengths, and only those lengths will be drawn onto the isometric projection. So here we have the datum line or the ground line. So this is our starting point. So this is our x-axis drawn at an angle of 30 degree. So the z-axis has also been drawn at an angle of 30 degree. Now this is our y-axis, which is going to contain this height of this hexagonal prism, that is this distance will be drawn along the y-axis. And as we have discussed, we are going to mark x dimension, that is this distance AB. So distance AB of the rectangle will be marked along the x-axis. Now I am going to mark, please check, distance x along the x-axis, and distance y will be marked along the y-axis, so that I can complete this rectangle ABCD onto the XY plane over there. So this dimension is equal to x. Similarly, this is again the isometric line which is parallel to the x-axis, and this dimension will also be equal to x. Over here, this dimension is equal to y, and this is again isometric line which has been drawn parallel to the y-axis, and its dimension will also be equal to y distance, that is distance of B to C. Now we can draw the length of this particular prism. So the length of this prism is given to us as 60 millimeter. Now we'll measure 60 millimeter along the z-axis and then draw this vertical line over here, and again you can see this is again, it is again an isometric dimension, and this is parallel to the y-axis over there, right? So let us complete the top face. In order to complete the top face, again see two isometric edges they have been drawn. So this edge, it is parallel to this edge, and it is parallel to the z-axis. Similarly, this edge, it is parallel to this edge, and again it is parallel to the x-axis. Now we can complete the back face as well. So in order to complete the back face, you see I have drawn three isometric lines. So this isometric line, it is parallel to the y-axis. This isometric line, it is parallel to z-axis, and this isometric line, it happens to be parallel to x-axis. Now we have obtained a rectangular prism to begin with, and the two faces of the rectangular prism, that is front face and the rear face. So this is the rear face of the rectangular prism, and both of these rectangular faces, they are going to provide us the 6 points of the hexagon which will be located by measuring the rectilinear distances into the true geometric figure over here. Now once we have drawn the front face, so we have labeled this as A, B, C and D, and now let us first of all work out the points which are there corresponding to the rear face. So they happen to be corresponding to A over here. We have A1 at the back. Corresponding to B over here in the front face, we have B1 at the back. Similarly, you have C1 corresponding to C and D1 corresponding to D point. So all the points of the rear face, they have been located and plotted. Similarly, all the points of the front face rectangle, they have also been plotted. Now, next step is we are going to work out the access point of the front face. So how do we evaluate access point of the front face? We measure the distance between point A and point E. So this will be the distance between point A and point E, and once we measure this distance, a vertical center line will be drawn over here. Similarly, we measure the distance between point B and point F over here. This is the point F. So we measure the distance between point B and point F, and please check, once we plot this distance over here, another horizontal center line will be drawn. So the intersection of these two center lines will provide us with the access point in the front face of this hexagonal prism. Now similarly, we have plotted the center point or the access point for the rear face. So same way, we have measured the distance between A1 and E1, plotted this vertical center line. Similarly, we have measured the distance between B1 and F1 and plotted this horizontal center line. So the access point in the back face, access point in the front face, they have been located. Now we have to work out the location of these 6 points, 6 corners corresponding to the 6 edges of this hexagon into the front face as well as the rear face over there. And which distances we are going to take? Rectilinear distances. So please check, the distance between point A and point 1, it is equal to distance between point B and point 2. So this is equal to distance between point C and point 4, and it is equal to distance between point D and point 5. So straight away you can check A1, B2, C4 and D5. So by measuring only one distance, 4 points we have been able to plot over there. So C to 4, D to 5, A to 1 and B to 2. So all these distances, they will be equal. Similarly, B to 3 distance and A to 6 distance. So both these distances, they are equal. So these distances, once again, we are going to mark it over here. B to 3 and then A to 6. So all the 6 points of the hexagon, corners of the hexagons, they have been marked into the front face. Similarly, all these 6 points, they have been obtained in the rear face, that is A1 11, B1 21, C1 41 and D1 51. So all these distances will be equal to this one, A1 or 2B or 4C, or it will be equal to D5. Similarly, B1 31 and A1 61. So this distance will be equal to either B3 or A6, because both these distances, they are equal. So now once we have marked the 6 points of the hexagonal face in the front as well as in the rear face of this hexagonal prism, now we are going to join whatever edges they are visible to the observer dark, and whichever edges they are not visible to the observer, they will be drawn with the lighter construction over there. So please check, the front face, all the edges will be dark, but I did not darken this one. Why? Because I am not going to darken the top face edges even though they will be dark, because I have to locate a right circular cone on top of a hexagonal prism. So if I darken all these edges, then what will happen? Once I draw a cone, then certain portion of the darkened edge which is lying on the top surface of this prism, they will not be visible to the observer over here. So those portions I have to leave as thin construction lines, and whatever uncovered portion of the top surface will be there, that portion I have to darken it over there. Now that's why even though this should be dark, but I have not darkened it to begin with. Even these two edges, 5 and 5 1 and 4 and 4 1, should have been drawn dark. but here I have to draw a cone. So that is why I did not darken it in the first instance, but ultimately these two edges, they will be darkened. Now next you have 3,1 and 4,1, this edge is visible to the observer. Similarly 3 and 3,1 will be visible, 2 and 2,1 will be visible to the observer. So these are the edges where no overlapping through the cone will be there. That is why I have darkened all these edges over there. Now once these edges they have been darkened, I need to work out which of the edges they will not be visible to the observer. So please check edge of the back face, that is 5,161, 6,111 and 6 and 6,1 and 1 and 1,1. Similarly 1,1 and 2,1. So please check 3 edges of the back face of the hexagon and 2 longer edges of this hexagonal prism. They are to be drawn hidden basically. So they are hidden, they have to be drawn with a lighter construction line. You cannot draw a dotted line in the case of isometric projection. So since these edges are hidden, even we can afford to omit them, right? Because they are no longer visible to the observer, as the observer is going to look from this side. So since the observer is going to view this hexagon from this side, so these lighter edges 6, 6,1, 5,1, 6,1, 6,111, 1,121 and 1 and 1,1. So in this case we have shown you that we should get the complete construction of the hexagonal prism. We should get the feel of the back face, we should get the feel of the front face, and we should get the feel of all the longer edges which have been joined, right? So all the 6 vertical edges, they have been joined over here. But now since I have to draw a cone which is going to rest centrally over this particular surface, which is this surface, this one, this is the surface, this is my top surface of this hexagonal prism onto which my cone is resting. And now you can see these values, that is whatever these dimensions are there, A1 D1, 5,161 and this 0.61 and 6,111. So similarly 6 and 6,1. So these lighter construction lines, they are going to interfere with the construction of the cone over here. So these lines might create the doubt that which are the lines which are corresponding to the cone and which are the lines which are corresponding to the prism. So since I have told you that these lines, these edges, they are not visible, so we can afford to even eliminate them or remove them. So now you see I am going to remove some of these lines which might be interfering with the construction of the cone on the top of the surface. Now I have drawn the center line, mark the access points O and O1. Now I will be eliminating these lines. Please check. I have eliminated some of these lines because these lines, these edges, they are not visible, right? So since these edges, they are not visible, I can afford to take them out. Now by removing these lines, now you can check, I have got a clear picture. Even this edge I have removed. One by one I have removed these edges. Please check. Initially we had all the edges which were not visible still drawn, but we had drawn it using a construction line just to show you that you get the feel of this completed hexagonal prism. Now since these extra lines, they are going to interfere with the construction of the cone, I have removed some of these lines so that now more space, more clarity regarding construction of the cone will be available over here. Okay, so let us start with now the construction of the cone. Now this cone is resting centrally on top of this surface of this hexagonal prism. Now let me find out the center point. So please check, this is the surface of the cone. So the center point line I have to draw through this particular position. So these are the center line. I can draw the center line of CD. It will be same as center line of 5,4. Similarly, I will be finding out the center of the line or the edge C1 D1, and similar will be the center line for 4,1 and 5,1. So once I locate this point and this point, so the center line can be drawn over here. Similarly, along this direction, now I am having a longer edge, that is D and D1. I will work out the midpoint of the edge D and D1, mark a point. I will be measuring the midpoint of this edge C and C1. Mark a point over here. and then join this center line. So I have been able to successfully obtain the center of this surface. What is the center of this surface? Please check. 5, 4, 4, 1 and 5, 1. So this surface center line happens to be this one. Now my cone should be resting over here, and I know that if I have to draw a cone, the top view of the cone will be a circle over here, and I cannot draw a circle into the isometric projection straight away. So circle appears to be an ellipse in the isometric projection. So in order to draw the ellipse, what I have to do? I have to inscribe the circle into a square, and that square, which will be having the dimension equal to 20 millimeter. This is 20 millimeter diameter. So this circle of 20 millimeter diameter can be inscribed into a square which will be having the dimension 20 by 20. Now over here I have to draw a square 20 millimeter by 20 millimeter. I have already got this 20 millimeter. Why? Because the edge of the hexagon was 20 millimeter. Another verification is this side view, which gives me a suggestion that the diameter of the cone is equal to edge of the base of this particular prism. So this is base is also 20 and diameter is also 20. So this side I have got 10 millimeter from the center on this side. I have got 10 millimeter from the center from this side. So this is already 20, no problem. Now had this circle been of the diameter 30 millimeter, then I would have taken 15 millimeter from this side, 15 millimeter from this side, and similarly 15 from this side and 15 from this side. That would have given me a square of 30. But since the diameter of this cone is 20 only, so this is going, these two lines, they will be forming the guideline for generation of the cone, because this distance over here is already 20 millimeter. Now what I have to do in order to get a square, I will be drawing two projector lines, one on this side, one on this side. So both of these projector lines will be having an offset of 10 millimeter from this axis line. So both of these projection lines, they are going to have an offset of 10 millimeter from this side. Now you can check, this is my 20 millimeter total length, and since this is also 20, this is also 20, so this distance is already 20, which was given to us in the form of edge of this hexagonal prism, and this distance I have marked as 20 millimeter. So what I have obtained, please check, this is a square which I have drawn on the top of this hexagonal prism. Now once I draw the square, I know that using 4 center method I can draw an ellipse in the square that which is existing over here. Now in order to draw an ellipse, I know that even though I have drawn a square over here, so square appears to be a rhombus in the isometric projection, and when I join two diagonals of this rhombus, please check, this is a major diagonal, this is a minor diagonal. So my focus of attention is right now on the minor diagonal, and now what I have to do, we have obtained the midpoints of 4 edges of the square. Please check, this edge midpoint, this edge midpoint, this edge midpoint and this edge midpoint. Now from every corner, you see, of this particular minor diagonal, so there are 2 corners of this minor diagonal. So from one corner, you see, I am going to draw a projector which will be joining the midpoint of the opposite edge. Similarly, on the other side also, I will be drawing another projector which will be joining this midpoint over here. Similarly, from this side, again from the second corner, I have joined a projector which will be joining the midpoint of the opposite side. Similarly, there is another midpoint which is corresponding to the second edge which is lying opposite to this corner. So I have been able to draw 4 projectors from these 2 corners. First 2 projectors were drawn like this, and they were joining the midpoints of the opposite edges of this particular square. Similarly, from the other corner of this minor diagonal, another pair of projectors they have been drawn which will be meeting the midpoints of the opposite edges. Now these four centers they have been obtained. Please see, center 1, center 2, center 3 and center 4. And these are the numbering of the centers. Center 1 is this, center 2 is this, center 3 is this and center 4 is this. So from center 1, I'll be opening this radius, or this radius will be drawing an arc over here. So this is my radius from center 1, this is my needle point, I'll be drawing this radius. Similarly from center 2, I will be opening the compass is equal to this much, or open compass equal to this much, draw the second arc using the compass over there. Then from the third center, my radius will be this much, or my radius will be this much. I will be drawing an arc equal to this radius from this point to this point. So third arc has been drawn. Similarly from point C4 or the center C4, my radius will be this much, or my radius will be this much. Again I will be drawing an arc, and this will lead to the completion of the ellipse, which is going to represent the circular portion of the cone. Now I know the axis. How much is the axis? 30 millimeter. So this is my axis line. This is the 30 millimeter height of the axis that I have shown. And from this center point, again I have shown the axis. And now from this center point, we have measured this distance is equal to 30 millimeter, and the apex point of the cone has been located. Now we have the apex point of the cone, we have drawn the base of the cone. Now the slant generators, they will be drawn to join apex and this tangent to this ellipse over there on either side. So these are the boundary generators that we have drawn over here. So two boundary generators will be drawn starting from the apex or the vertex point, and they will be joining this ellipse in the tangent form over here. Now with this we have completed the construction. Now let us join those sections which are visible to the observer. Now regarding the cone, so these are the outer boundary generators, so they are visible, they will be drawn dark. This portion of the semicircular portion of the cone will not be visible because it is lying on the inner side, whereas this portion of the cone will be visible to the observer. So we have drawn this portion. Now the cone is now covering, you can check, this portion of the top surface of the generator, which is 5 and 5-1. So corresponding to this edge 5 and 5-1, this portion has been covered by the cone. So we will not be able to see this. So again it is the lighter construction line. So what we have to do, we have to darken the remainder portion of the edge 5 and 5-1. Similarly 5-1, 4-1 will be joined, 4 and 4-1 will be joined, and 5 and 4 will be joined. So this is the complete construction of the cone, which is resting centrally on top of a hexagonal prism, which is resting on one of its rectangular edges onto the base over there, right? So the similar problem now we are going to pick up regarding the sphere. So please see, rest of the construction remains the same. So we are not going to carry out the explanation, but just a little bit recap we will be doing. So here along the x and y plane, this hexagonal shape has to be obtained. So we have inscribed this hexagon into a rectangle, and this rectangular front surface will be drawn along the xy direction. Along the z direction, the length of this prism will be shown, and once we extend all these, you see, isometric lines, the front face and the rear face of the hexagonal prism, they have been drawn. And after drawing these, now we have to work out the center points of the front and the center points of the rear face over there. Then we have marked the 6 points of the hexagon in the front face and 6 points of the hexagon corresponding to the rear face. And once again, as usual, we have joined those edges dark which are visible to the observer, but there is an exception because the edges 1, 2, 3 and 4. So these 4 edges should have been drawn dark, but they have not been drawn dark in the first instance because we have to locate a sphere centrally on top of this rectangular face. So on the top of this rectangular face, we have to locate a sphere. but certain portion of the sphere, it will be covering these four edges over there. So these four edges we will be darkening at a later stage once the construction of the sphere is completed over here. Then these edges, they are visible, so we have darkened them because these are the edges which are available on the side view, right? So this side is not going to be covered by the sphere. And then we have shown even those edges of this prism which are not visible to the observer, but still for the purpose of obtaining the clarity about all the edges of this hexagonal prism, we have drawn those edges. So what are those edges? 5161, it has to be drawn light. 6111, 1121, 1 and 11, and 6 and 61. So these two longer edges and three base edges, we have drawn lighter in nature. And then we have even joined the axes over here, front face and the rear face. Now whenever we'll go for construction of the sphere over here, we'll find that these are certain edges which were otherwise not required, but just we had drawn them in order to improve the clarity about the visualization of this particular hexagonal prism. So we can even remove some of these edges because these edges, they might be interfering with the construction of the sphere over here. So please check, I have removed some of the edges which would have interfered. Now next is since this sphere is going to rest centrally on top of the top surface, please see, this is my top surface of the hexagonal prism, and our sphere is going to rest centrally on top of this top surface of the hexagonal prism. Now we have worked out the center point so that I know the point where my sphere will be resting centrally on top of this top surface of the prism. Now having located this center point, I know that how much is the radius of this particular sphere. The sphere is given to me as diameter. Please check, the diameter of the sphere is given to me as 60 millimeter. So the radius becomes how much? 30 millimeter. And one thing we must remember while we are trying to locate sphere in isometric projections, that even if you view the sphere from any given direction, maybe on HP, maybe on VP, maybe on AIP, maybe on the AVP, whenever you are looking at sphere from any angle, its projection which will be obtained, it will be always a circular portion, and there will not be any reduction of the dimension of the sphere when you draw this particular circle. But there is one thing which will be affected in the isometric projection. This thing is the radius, because the radius of the sphere, please check, this is my radius of the sphere. So this is the radius of the sphere. This radius, it is a linear dimension. So since this radius of the sphere happens to be a linear dimension, and in isometric projection all the linear dimensions, they will be curtailed, they will be foreshortened or reduced by 18%. So what we have done, please check, we have marked the isometric radius is equal to 30 millimeter multiply by 82% equal to 24.6, or otherwise I can mark this 30 millimeter over here and obtain whatever isometric length is obtained corresponding to this true length of 30. So this will be my isometric radius, right? So even if we don't want to use mathematics over here, we have the isometric scale. Rather we will be using it just for the purpose of showing you that how much reduction is there. That is why I have multiplied these two values. Otherwise we would have taken this value only. So this value of which is obtained on the isometric length scale is 24.6. So what we have to do, from the center point, so please check, from the center point we will be drawing the axis height, that is the axis we will be drawing, and on this axis of the sphere I am going to mark the distance which will be equal to the R isometric, that is equal to 24.6 millimeter. So please check, along this axis line I have marked this radius which is equal to 24.6 millimeter, but here I get the center point. But one thing I need to know, that when I start drawing this circle, now the circle radius will always be 30 millimeter, so that I get the sphere construction for this particular circle, which is going to give me the diameter of the circle is equal to 60 millimeter. So we should remember that there is no reduction in the diameter of this particular sphere, because sphere will always look like a sphere whichever angle you might be viewing it from. So only thing is the radius has been reduced, but that's the only thing. So through this radius the point O has been located, and then through O, when you start drawing the circle, we have to take the radius is equal to 30. Now you can check this particular around 5.4 millimeter is the distance by which it might appear that this sphere bottom has overshooted the center. No, it's not like that. It is only because this surface, you can check, this surface is inclined, so sphere is resting right here at this particular point on one of its points of its circumference. But because of this inclination of this surface, we will be able to just perceive, it is not actual, but we will be perceiving that the center might have shifted slightly towards the observer. So whereas the fact of the situation is that the sphere is resting at this particular point onto the top surface of the hexagonal prism, right? So only in the appearance it may appear that the front view has shifted over there. So even though there is a gap which might be appearing in the front view, but the sphere is touching at this particular point only. Now we can see there is one edge 5 and 5-1, there is another edge 4-1 and 5-1. Please check, these are the two edges which our sphere has covered them partially. So that is the reason that even though this edge, this edge, this edge and this edge, they had to be drawn dark, but we did not draw them dark right on the first instant. Now we have to darken the edges which are visible to the observer. This is visible, darken it. Similarly, this edge, it has not been covered by the sphere but visible to the observer, darken it. I would have darkened this total edge 4-1, 5-1, but portion of this has been covered by the sphere, so this will not be visible to the observer. So now I can darken only 4-1 and this point. Similarly, 5 and this point have to be joined dark, because this portion of the segment 5 and 5-1 has been darkened or covered by the sphere. So this is the complete construction of the sphere which is going to cover the hexagonal prism. Now next we move on to a cylinder which is resting on top of the hexagonal prism. So once again, so since the prism remains the same, so we are going to now take up the construction of the prism in a faster mode, because we have already discussed this construction before. Now front face, top face, once again the construction of the hexagonal prism has been completed, and all the edges which were even not visible to the observer, they have been drawn to begin with. Now I am supposed to mount a cylinder on top of this. Please see, I am supposed to mount a cylinder on top of this. What are the dimensions of the cylinder? Please note that the cylinder is having the diameter equal to 40 millimeter, and the axis height of the cylinder is given to me as 60 millimeter. So let us read out the statement. A cylinder of the diameter 40 millimeter and axis height 60 millimeter, it rests centrally on top of a hexagonal prism of side 25 millimeter and length 60 millimeter. So I have been given with the length is 60 and the edge length is equal to 25 millimeter. Now it is resting on the ground on its rectangular faces. So this part we have already completed. Now since we are required to draw a cylinder on top of this, so again these edges, please check, these lighter edges, they would be interfering with the construction of the cylinder. So now I am going to remove those edges. Please check, I am going to remove few edges which might be interfering with the construction of the cylinder on top of this particular hexagonal prism. Now please check, this hexagonal prism top face. What are the dimensions of this prism? Let me know. 25 millimeter and this is 60 millimeter. So this is 60 and this is 25. This one is 25. But the cylinder which is going to rest on top of this face, which is going to rest centrally, this dimension is given to me as 40 millimeter. So what I have to do, I cannot construct the ellipse corresponding to that cylinder straight away over here. So what I have to do, I have to draw the circle first of all, having radius is equal to 40 millimeter, and after that I will be inscribing this cylinder or the circle into a square portion. And what would be the dimensions of that square? The dimensions of the square would be equal to 40 by 40. Now this 40 by 40 size I am required to draw on top of this, but please check, this width is only 25. So what will happen? My cylinder is going to overshoot this particular surface. That is, my cylinder will be drawn over here. Please check. I will be drawing a cylinder. If this edge is equal to 40, then both of these two things, they are going to match. If my 40 millimeter is shorter than CD, so cylinder will be drawn within this portion. If my 40 millimeter is going to exceed CD, then my cylinder is going to be drawn even beyond this particular thing. So once you make this exact construction, now then you need to make the comparison of this X distance, that is the distance between AB and the 40 millimeter. So whichever is bigger will be drawn in a bigger size over here. Now we have worked out that this X is approximately equal to 40 over here. So that is why I have carried out this particular distance equal to X over here, right? So I have drawn a square. Please check. I have drawn a square with respect to these two center lines. I have drawn an offset of 20 millimeter from this side. I have drawn an offset of 20 millimeter from this side. So this gives me this width is equal to X is equal to 40. Similarly, corresponding to this axis line, on the left side, again I have drawn a projector line with an offset of 20 millimeter. Similarly, on the right side, I have drawn another projector line having an offset of 20 millimeter. So please check, with respect to this reference line or the center line, 20 millimeter offset line, you see blue line, sky blue line which I have drawn. So it has been drawn over here. Second projector line, again it is having an offset of 20 millimeter from the axis. Similarly, from this horizontal axis over here, another projector with an offset of 20 and another projector with an offset of 20 has been drawn. So please check, I have been able to draw a square of edge 40 on top of this. And please check, if CD is not equal to 40, then if CD is greater than 40, then this blue line, this will be lying within this particular CD. If CD is shorter than this 40, then the blue lines might be overshooting even beyond CD distance. That is the only thing, right? But the procedure will remain the same. So once I have drawn the square of 40 millimeter dimension on top of the surface of this hexagonal prism, now I need to draw the vertical edges. So how much is my vertical edge? 60 millimeter. The axis height is equal to 60 millimeter for the cylinder. So please check, I am going to draw a square prism over here. So this is my square prism. You can check, the edge of the square happens to be 40 millimeter. The height of this prism, it happens to be 60 millimeter. So this square prism has been drawn on top of this hexagonal prism and it is resting centrally on the top of this surface. And now, having drawn this square, so the top face square, it looks like a rhombus. The bottom face square, it looks like a rhombus. And now I have to draw the circular portion of the cylinder over here at the top face. I have to draw the circular portion of the cylinder at the bottom face as well. Now let us start with construction of the circle. So in a rhombus, what happens? We have a longer diagonal, we have a shorter diagonal. So this is the minor diagonal This is called the major diagonal. So our focus of attention will be minor diagonal. So we have obtained the midpoints of all the four edges. So from this corner, I am going to draw two projectors which will be joining the midpoints of the opposite edges over there. Similarly, from the second corner of the minor diagonal, I am going to draw two projectors which will be joining the midpoint of the opposite edges over there. And once I draw these four projector lines from the two corners of the minor diagonal, I have obtained four centers, because the method which is used to draw an ellipse which is going to represent the circular portion of either a cylinder or a cone. So this method is called four center method. So the centers, they have been located: center 1, center 2, center 3 and center 4. So from center 1, please check, I will be taking this radius or I will be taking this radius. So using this or this radius, using C1 as the center point, I am going to draw one arc over here. Similarly, using C2 as the center, radius will be equal to this distance or radius will be equal to this distance. I am going to draw the second arc using C2 as the center. Similarly, with C3 as the center, my radius will be this or my radius will be this distance. And then the third arc will be drawn over here. Similarly, with C4 as the center point, radius is equal to this one or this one. So the fourth arc has been drawn. So similarly, four arcs will be drawn corresponding to the circular portion of the cylinder at the bottom. So once again, there is the major diagonal, there is minor diagonal. So had we not removed those lines, you can see there would have been so many interfering lines over there. Now this is the minor diagonal. Corresponding to the minor diagonal, again two projectors from one corner, they have been drawn to join the opposite midpoint of the edges over there. Similarly, from the second corner of the minor diagonal, we have drawn two projectors which are going to join the midpoint of the opposite edges over there. So four centers will be located. Please check: center 1, center 2, center 3 and center 4. So similar to this construction, so four arcs will be drawn. Arc 1 corresponding to C1, corresponding to C2. Arc second will be drawn corresponding to point C3. This will be the radius. Arc C3 will be drawn, and corresponding to point C4, fourth arc will be drawn. So this is the circular portion of the cylinder which appears to be an ellipse on the top face has been drawn. This is the lower portion of the cylinder which again appears like an ellipse, and it has been drawn on the bottom face of the cylinder. Now having completed the top face and the bottom face, now we have to join the edges which will be appearing to the observer as the darkened one. So this edge will be dark, drawn dark. So this is the edge which is visible to the observer. This is the boundary of the cylinder, drawn dark. So the top face of the cylinder, it will be visible to the observer. So it has been drawn dark. And this portion, please check, this semicircular portion of the bottom of the cylinder, this will be visible to the observer. Again it has been drawn dark. And this is portion of the ellipse which is not visible to the observer. So this has been left with the lighter construction. Now we can see even the edge 4 and 4-1, part of it has been covered. Even the edge 5-5-1, bulk of it has been covered by the cylinder. So whatever remaining portion of the top face of the prism is there, we are going to now darken those edges. Even you can check 4-1, 5-1. So part of it has been covered by the cylinder. So only the remaining portions we are going to darken. So this portion we have darkened, this portion we have darkened, this portion we have darkened because this is visible to the observer and not covered by the cylinder. Similarly, this one and this one, right? So these things, they have been not covered by the cylinder, they are visible to the observer. So that's why the remaining edges of the hexagonal prism which are visible to the observer and not covered by the cylinder have been shown over here. So this is the construction of a cylinder which is resting in the upright position on the top of a hexagonal prism, right? So with this discussion, we have been able to cover 3 questions in this lecture in which there was a common point. So this common point was the hexagonal prism which was resting on its rectangular face onto the ground. And we will be continuing with further discussion on few more cases of the isometric projections in the coming lectures. So this is all for today. Thank you very much. Thanks a lot.